with that button. Mutter, mutter. All right, let's take a minute to check in and cleanse our palates, our mental palates. Just settling in and coming into your body, into this room, whatever that means for you. And awareness. All right, my friends, so I'm going to start off with a couple examples. As I said, find the equation. I'm going to do two of these. Find the equation of the cline through. I'm going to do two of these, kind of just like the two that you have. So the first set of points are I1 and 2 minus I. Before I do anything, I would plot these out, and I recommend you to do the same. Draw a picture whenever possible. So we've got I, we have got 1, and we have got 2 minus I. Notice anything neat about those? What are you noticing, Lou?
It's just a line.
They seem to be on a line, right? So that makes life better for me. And in fact, we could easily prove that these are on a line of slope -1, right? In fact, they are on a line, a slope -1 with y-intercept 1, so I could just write the equation if I wanted. But that's not the equation we want. We want the equation of a cline in this form. And now, so here, notice that out front there's this part, but this is only if there's a circle. So I can immediately take that variable out and say, oh, cool, I've got less to deal with here, less to manipulate, because I know this is a line. So here, I'll just make a little note here. Remove or C equals 0 because we have a line. And then the other example is not a line. So we get a little of both worlds. Here's some tips. I've been working these all weekend, just trying to think of things that might help, trying to make this a little easier. So the first thing I would recommend is to replace alpha with a generic complex variable, a plus bi. It'll really make life so much easier for you. Then I'm going to create, using this, and my points that need to be on that equation, I'm going to create 3 equations from that. So the first equation, so here, let me just put some little notes here. Plug each point into star, and star is this beast up here, and get 3 equations. And the equations are going to be in terms of A and B. Those will be the only well, and then D as well. So the equations in A, B, and D. One thing to keep in mind is that this D is always a real number. So if it turns out, if you're doing these computations and that D starts to look imaginary, you've probably screwed something up. I know this for a fact. because I did it many times over the weekend. So take it from me. So plug each point in. First thing, I'm going to plug in I. So I'm going to plug in I, and what I'm going to get, now this is the Z, right? So this is just Z equals I. And this is kind of, I didn't mean it like that. I meant it like that, sorry. So I'm going to have A plus BI times Z, which is I, plus A minus BI, so that's alpha conjugate right there, times Z conjugate, which is minus I. Oh my God, please be so careful with this. I also spent a lot of time suffering because I didn't conjugate that thing either. And it just ends up screwing your life up. So just plug it in, and then I'm going to recommend reorganizing it into a real part and an imaginary part. So then I'll write this out here. Now group the real and imaginary parts. And you probably need to multiply this all out a little bit. So let's do a little bit of work here. This is AI minus B minus AI. And then there's a lot of negatives here. So this negative becomes positive, but then I squared makes it a negative. So it becomes minus B plus D equals 0. Notice how good stuff happens with the imaginary parts. They die off, they cancel each other, and I'm left with negative 2B plus D equals 0. Let me stop. Tell me if this is feeling okay, if there's any troubles. Okay. Some sweet point coming up here. 1. That is a dank point. So we're gonna let Z equal 1. And what are we gonna get? We're gonna get A plus BI times 1. I'll write it out so that we have it recorded for our video and our notes. And then alpha conjugate times 1 plus D equals 0. So now the BI's are going to cancel, and I'm left with 2A plus D equals 0. Nice. Ooh, look, I can make some conclusions already because both these things involve D. So notice that this one here says that D equals 2B. And so this D is 2B. So in other words, A would have to be negative B. So when I plug this in here, put these together, I've got 2A plus 2B equals 0. And from there, I already have a nice little relationship that A and B have to be opposites of each other. And having little facts like that can sometimes make later computations better. So let me stop. You tell me if that sounds okay. And if I need to talk about any of it, you'll let me know, I hope. Yeah, oh, hell, yeah.
So the conjugate of 1 is just still 1. It doesn't
Correct.
become negative 1?
That's right.
Why?
So remember how conjugates work. Conjugate of Z is you just negate the imaginary part. So if this is A plus BI, then this is A minus BI. But if I'm already real, I don't have an imaginary part. So the conjugate of a real number is just that number.
Okay.
Does that make sense? Could you crank out, just to make sure we're on the right page, the next point, please? So what equation are you going to get for Z equals 2 minus I? This one actually involves a little bit of work. And I'm going to step out, run to the restroom. If you can, get this equation and then solve for A, B, and D. I'll be right back. Hopefully. Good. Getting here? Yeah? Any questions on getting there? Any troubles? I've done this a bunch, so I'm just like automatically grouping together reals and imaginaries up here. Cool on this? Awesome. So now at this point, it's solve 3 equations and 3 unknowns. And there's a gajillion ways to do this. Let's write our equations out together. So we have this one, we have our first one, which was negative 2b plus d equals 0, and then we had 2a plus d equals 0, and we just got to solve those. We already know that a and b are opposites. I don't know if that gets us anything. Let's see. I kind of think these might be dependent. I think these might be dependent. Oh, here's a good one. Let's see. Check this out. If I add these 2 together, so if I take those and add them together, I get 4a plus 2d equals 0. And then I can combine that with this one down here, which is actually the same damn equation. So, yeah. Cool. I kind of have a feeling we have infinitely many solutions here. Did anybody come up with a solution? There's many, yeah. Because I think that we really only have 2 equations worth of information here and 3 unknowns. And if you've ever had linear algebra, this is an underdetermined system. So what we can do is, oh, here, check this out. And let me, oh, Ella, were you gonna say something?
No.
Okay, cool. Cool. Spazzing out. Notice that if d is some value, we could actually rescale this whole thing in a bunch of different ways. So for example, if d turned out to be 2, I could make it a 1 just by dividing through this whole equation by 2. So what I think is we can pick a value for d here. So let's choose d equals 1 and see if this is going to work out. Because I think that we have one free variable here. One variable is free. That kind of makes sense just on that loose stuff I just set up there. So if d is 1, then that would make a negative 1/2. And then that would make b positive 1/2. And we have a solution. And our solution is going to look like this. And let me write it out, and then you'll see that the argument I gave over there is a-okay. So in other words, alpha is this number, this a plus the bi, and our equation is going to look like this: negative 1/2 plus 1/2 I z plus the conjugate of this, z conjugate, plus our d is 0. And you can kind of see how I can scale now, right? I could make that d a 2 and make these nice non-fractions if I want to just plow through by a 2. Make it pretty. Does this sound good? So we have our equation of our line. Here's how you could also do this. We have a problem, and I don't know if I assigned the problem. I think I might have. Did I give the problem find the inversion of this in the unit circle? Yeah, so once you do that, since we knew that this thing was y equaled negative x plus 1, we could literally use that result there as well to see what this image would be. And let's double check and make sure everything's looking kosher and pull together some things. So that result, I don't know it off the top of my head. This is a big chapter. A lot of content in here. So this is problem 5. In problem 5, the inversion of that line over the unit circle is a circle with center minus m over 2b, comma 1 over 2b, and then the radius, so that's your center, and then your radius is going to be square root of m squared plus 1 over 4b squared. So let's compare to what we have up there. This thing should be a circle with a center of -1 over 2, so positive a half, comma 1 over 2b, so that's just 1/2. So it should be a circle with the center, and then our radius should be square root of -1 squared plus 1 is 2 over 4 times 1 squared, so square root of 1/2. How can I know? Oh, yeah, what's up? Please tell me.
Why is it a circle?
Oh, we didn't have to do inversion, did we? Oh no, I'm kind of working on a new problem
Okay,
on my
good.
head. Sorry, yeah. This, yeah.
No, you're good.
Yeah,
I was just
yeah.
like, I thought
Yeah,
it
I don't know,
was
sorry, I was like,
wrong.
I've been inverting so much shit over the unit circle that I just started doing it automatically. So thank you for stopping me. Thank you for stopping me. How could I check to make sure that this is the right answer? Let me pull back. I've literally been inverting stuff like all day, every day this weekend. How could I check to see if this is the right answer? What result in our book or from a quiz could I use to check myself? Yes, that's there. Christian's got the right idea. He's grabbing for the book very slowly and carefully. And he's flipping through it. Do you remember the quiz? Remember that quiz? The equation of a line, and where we can grab stuff about the line. Wasn't that part of the quiz? Yeah, lines and circles, page 30. So on page 30, a couple things you could do. You could plug these points in and make sure that they satisfy this equation. That's something I did a lot of this weekend. That's a cumbersome thing, but plug in 1 and see that it satisfies this. Look, 1 works here. When z is 1, I've got -1/2, -1/2 cancels with the 1, and then the imaginary parts cancel, so that's a sanity check. The other sanity check is that if I have this equation, that this is, this represents a line. If alpha is 1/2 a minus bi, this is a line ax plus by plus d equals 0. So we can take this, and we're gonna kind of come at this from the other side. So this put into this form is x plus y minus 1 equals 0. So here I've got a is 1, b is 1, and d is minus 1. And then I can see, is that the alpha that I'm going to get out of this thing? And it sure looks like it, right? Because here's 1/2 1 minus I, and 1/2, the conjugate of that'll be 1/2 1 plus I. And it looks like I'm rolling along here just fine. And then what was D? D is minus 1. So it's not quite syncing up. Why is it not syncing up? Do you see what I'm talking about? And it's okay. I want you to see what I'm talking about, and maybe I should be clearer about what I'm talking about. So, sorry, a little spastic here. Feeling myself in spaz mode, I apologize in advance. But do you see what I'm doing here. Does this need better explanation? I think so. This is by the absolute non-responsiveness. That makes total sense. So, did everybody agree that the 3 points satisfied this? That made sense, right? So when we come to our book, it says that if you have this equation, you can convert it into this form by letting alpha be 1/2 this number minus this I. So it tells us how to move from this form to the form we're actually trying to get down here. So I took the thing that we grokked immediately by just knowing stuff about lines, and I rewrote that in this form, like that. So now that looks like this. So if I was coming at this problem in a naive way, just using that result from the book, I would say, okay, here's the line that I have. Let's convert it into this form. So alpha here would equal 1/2 the A minus the B, which is 1I, and that would be my alpha. So in other words, alpha is 1/2 minus 1/2 I. What is my D? Notice that my D is -1. Just by comparing this with this thing right here, just laying that on top of that and grabbing those numbers. So is this the same equation, I guess is what I was trying to say. It is. It doesn't quite exactly look the same, right? We have to multiply through by a -1. So if you multiply this by a -1, you actually get that alpha. See right here? If I change this to a plus, minus, plus, plus, and a minus, it syncs up perfectly with what we need. So a couple sanity checks, as insane as that exposition was. Thanks for your patience. Thanks for coming back to class. So let's take a look at the other one that we had. And I want to tweak the points that I gave you just a little bit. So the 3 points that I'd like to try on this next iteration are these. See, what were the 3 that I just had? I had I, 1, and then I had 1, 2 minus I? Yeah. So what I would like to do this time is use I, 1, and then minus I. And once I plot those out, I see I don't have a line, right? Hopefully I see that. But you might not see that until you plotted them. So we know that this has to be a circle. There's only 2 possibilities for our clines. They are lines or they are circles. So we must have this form right now. C, ZZ conjugate plus A plus BI, Z, plus A minus BI, Z, plus D equals 0. And I'm gonna play that same game again. I've got these 3 points, and I've got these 3 equations that I'm gonna generate from them. So let's could you just take a minute and do that with me? Thank you. I am blue. Yeah, you're right. Thank you. So let's see here. And one thing to remember is that's just the modulus squared, that first bit. So that makes that little bit easy. I would simplify them as you go through. I think in all of these, you're gonna get to some point always where you can choose one of the variable values. I'm pretty sure that's a true statement.
Why do you have -b for the second one?
For this guy here?
Yeah.
So let's see, so we had a negative and a negative, so that became a positive, but then I had I squared,
Oh.
and that gave me that, who's asking that? Oh, it was Grace, hi, yeah. Thanks for checking me though. Definitely need adult supervision most of the time. So let's see here. And then our last one. Let's see. Imaginary stuff. Well,
You didn't conjugate the second.
yeah, I was gonna say this should. That's how, yes. And I saw that I wasn't gonna cancel my imaginary shit and immediately knew something was wrong. So yes. Good call, Lou. There was a serious problem. Yep, that becomes plus I. And I've made that mistake so many times this past weekend. So now the imaginary stuff cancels. Life is way better. And then that becomes a plus B. Cool. Yeah, cool. And then once again, we end up with 3 equations. This time in 4 unknowns. So we certainly have a degree of freedom. In fact, I think it's kind of weird that they put this C in front at all, because you could just always put a 1 here. If you just divide it through by C. If C is not 0, just divide through by C. And then it just gets absorbed into those things. So I'm not sure why they put that C there. But we can make a note that we have 3 equations in 4 unknowns. So 1 is free. And when I say free, that means we can set it to what we want. I would just set C equal to 1. You can set any of them and you'll be okay, but it's probably just easier to set that C as 1. And then we've got 1 plus 2a plus d is 0. We've got 1 minus 2b plus d is 0. I'm not lining things up very nicely here. And then we have 1 plus 2b plus d equals 0. And yeah, and then from there we can solve for a, b, and d. We should be good to go. Let me stop. Are everybody cool on how we could solve that system?
You know D or C is the free variable.
It could be any of them, Christian. It's the one I would want to make free anyway, so I think it couldn't hurt to just let C be 1. But it should work out it should come out in the wash that no matter which one I set, I'm good to go. The only thing I wouldn't want to do is let C be 0, because then I wouldn't have the equation of a circle anymore.
Sweet.
Yeah, nice. I like that. Are we all good on this? And then find A, B, and D? Yeah. And I think, well, let's just go ahead and finish it up, because I'm not sure, I'm not reading people clearly. A couple careful, folks. I'm not sure if I believe that this is okay because you're not acknowledging it with the head nod. So let's take a look. I would take these two and see what they say. And they actually look totally contradictory, don't they? But if I just take these two and add them straight down, I get 2 plus 2d equals 0. So add these two, and you get 2 plus 2d equals 0. So d is -1. That's sweet. Once d is -1, I get that b is 0. So plug that into here. And from here, this and 1 minus 2b plus d equals 0 implies b equals 0. And once b equals 0, wait, and then a equals 0. Wait, a equals 0? Oh, wow. Oh, this is cool. Okay, I didn't work this one all the way through, but I'm excited now. Since that looks scary, that scares me a little, but look at what it gives us. It's so beautiful. These 3 points were like this. That's the unit circle centered at the origin. And when we plug in all our gobbledygook, I've got c, which is 1, times the modulus of z squared, plus dead, and then d is -1. So what we get is modulus of z squared equals 1. And if you wrote that out in rectangular coordinates, it would just be that guy. So cool, it worked out. That's neat, yeah. I like it when I get surprised in class, that's fun. So that's what you have to do, my friends. These tips should hopefully, Tara, does that sound like a good plan on that?
I
Awesome.
didn't realize that the independent variables, like, you could choose, so I kept getting confused. I was like, well, now I don't know what I'm doing.
Yeah, it is confusing. It's a little confusing. And there was one more question that I was asked to talk about, and I would like to talk about that. And it is inversion in the unit circle. So let me give you some tips on that. We'll do an example together. So, find the image of the line. Let's see, what line would be good for us? Well, let's see, we're gonna flip in the unit circle. So how about that line right there that goes through 2 and 2? Why not? Let's do that. So that line is y equals -1 slope, y-intercept of 2, so that's my equation. In other words, x plus y equals 2. Find the image of this line under inversion in the unit circle. And what that means is that the variable z is going to be replaced with 1 over z conjugate. And it also means that every z conjugate is going to go to just 1 over z. So those are the 2 substitutions we need to make, but we need to first get a z equation. So we have this, but step 1 is convert this to this form. So that's step 1. And I wouldn't do this in the painful way. Yeah, I would. Yeah, I'm gonna do this in the painful way. So how? Because it's good to do. And it's not all that painful. Just, instead of just going and looking up formulas, we're not engineers. That's what engineers do. Engineers go look up stuff in a table. We're mathematicians, we build shit. I guess engineers might say they build shit too. We build math shit. So how? So I'm gonna use the fact that x is 1/2 z plus z conjugate. notice that if I take z plus its conjugate, the imaginary parts cancel, and I've got twice the real part. And similarly, if I take negative I over 2 times z minus z conjugate, that gives me the imaginary part. You could prove that to yourself if you needed to. But I'm going to use these and substitute them into my line equation. And sub into star. So what I'm going to get is 1/2 z plus z conjugate, that's the x. The y I just replace with this, equals 2. I'll probably want to move that 2 to the left at some point, but we're good to go. And then take this and regroup. So step 1 is do this. Here I would now group by z and z bar. So I'm going to group together all the z stuff, which is 1/2 minus 1/2 I z. And then my z conjugate stuff's going to be 1/2 plus 1/2 I z bar. And I'll just bring that 2 over while I'm at it. Let me stop. Do you see how I'm getting this? And if not, let's talk. Now's the time to let me know. So really, it's really pretty easy to move from a line in this form to this form. Just takes a little bit of work. The next step is to do the inversion. So step 1 is converted into this form. Step 2 is to replace every z with 1 over z conjugate and every z bar with 1 over z. So step 2 is now in that equation replace every z with its inversion and z bar with its inversion. So when we do that, we're going to get 1/2 minus 1/2 I, 1 over z bar. I just replaced the z with 1 over z bar. And then I've got plus conjugate, that thing, 1 over z, because that was originally z bar. And I'm replacing it. And then I've got minus 2 equals 0. Let me stop. We need to figure out what kind of this is going to turn into a circle. And the reason I know that is because I've still got this, we don't have any forms that look like this. So I've got to multiply through by z times z bar. So I'm going to multiply through by that product, and it's going to give me non-fractional z stuff. So this first one becomes 1/2 minus 1/2 I z, because the z bar cancels, plus 1/2 plus 1/2 I z bar, because the z canceled. And then here's the part that lets me know I've got a circle. So when I see this, I know there's a circle involved. I've got a non-zero coefficient in front of essentially x squared plus y squared. That thing right there. So now take this and turn it into this form, where we have cz bar plus alpha z plus alpha bar z bar plus d equals 0. And we know everything we need about this circle. We can just read this off the results. We don't have to go convert this into a rectangular coordinate thing, because we have the result that was another one of your quiz items on the last quiz. So I'm going to convert this into this form. In other words, gosh, I guess it's already pretty much there, right? It's just rearranging things. So we could say here that c equals -2, alpha equals 1/2 minus 1/2 I. And D, what's D? 0. D is gone. There's no D. So D equals 0. And then I go to that result, which is on page something or other. Page 45, the cline equation. So, given this stuff, I have a circle with center, and that's the negative real part of alpha, so negative 1/2 over the C, which is 2. So that's going to be negative 1/4. Oh, thank you, positive 1/4. Yes, thank you. Is that what you were saying, Lou?
Yeah.
That I had the sign wrong? Yeah, thanks. And then the imaginary part of alpha, which is negative 1/2 over C. So we got this. So our center is actually going to be at 1/4, 1/4, which looks reasonable. At least it's in the right quadrant. And our radius. So this is all, again, from page 45, that box on page 45. The radius is going to be square root magnitude alpha squared minus CD over C squared. And I'm not doing that. We can all do that. If we can't do that, then the rest of this is probably just gobbledygook. Right? So that's how we do that problem. Sound good? Let's take the rest of the today to just work on this homework, and while we're here together, consult if you need, consult with me, consult with others, work together, do what you need to do. But I'm done. The show's over. See, you were thirsty. You were very thirsty.
No, it was good.
Sorry.
Oh, no, you're
No,
good.
you're good. Okay. How are you doing? Yeah? You feel refreshed? Was it hard to come back? Probably. It's probably always hard to come back, I imagine.
Yeah, well, I don't really heard there was a shooting.
No. Oh my God.
Yeah.
Oh no. But you didn't know anyone?
No.
Okay, that's
not
good.
personally, but we were really close to it, so it was kind of freaky.
Oh my God.
Yeah, but I had like a lot of time, like, so I actually have. It was great.
Oh, that's terrible. God damn this world.
I know.
Ugh, so sorry. I
But-
took what was a really beautiful time.
It was so funny that that happened.
Luckily, I don't watch the news, so.
I'm about to stop watching.
Yeah, I think it's not a bad plan.
But yeah.
Good.
Wrap up.
Yay. Good. Yeah, I don't know what I said. Yeah, when do you need till? When? Friday. Okay. All right. Yeah, that's good. Yeah.
cute
I like
post.
it. Nice. It also looks like a rose, though. What did you think about
It was fine.
I have not heard good things, so I felt for you.
Wish that it was better. I
Yeah.
really like Spider too. It just was not. I feel like it's a TV show. They just put so many pieces of it. Like
That's-
from her birth to her death. They went from historicals.
Oh.
So fast.
Wow.
And my sister was just like rough. We're after the 16.
I know. I was feeling for you as I looked at those reviews. Well, at least you're there with someone you love.
Exactly. It's fun.
Yeah, that's cool. Yeah, you can laugh at it.
Yeah, no, it was really funny. We went to a sort of was afterwards, all four of us, and like the only option was the Madam Web like frame thing. And we were like,
Yeah, they have to force it upon you, otherwise you would not be choosing it.
I think we should watch just with the idea that it's like a funny movie.
When it comes when it's free.
Yeah, it's fair.
I really want to see Poor Things. That's the
What is it?
Poor Things with Emma Stone.
No.
Oh my god. Poor Things. It's not on. It's only in the theaters now, but I love Emma Stone.
Okay, I need to look it up.
Yeah, yeah.
I feel like I've seen so many things because my family is also mastered the art of showing up to the movies after the previews right before the movie.
Movies.
Well, that's the thing. We just happen to miss them because we're always late.
Oh.
But that means I don't know any of the movies that are coming out.
Gotcha. Yeah.
So it's called One Poor Thing.
Did you see La La Land? Okay, put that on your list.
I've been
It's
told
like my
it's
favorite.
really
That
good.
is my favorite movie ever. Hell,
Everyone who's ever seen it says it's really, really good.
it's like the most uplifting, beautiful film ever.
Okay, I need to watch it.
You do.
Because it's about jazz, right?
Kind of. Yeah. Kind of. That's part of it, but I would say it's about
It
jazz.
has jazz
It
in
has
it.
jazz in it. It's mostly about Ryan Gosling and Emma Stone being like incredibly talented.
That's cool.
Yeah. Yeah.
That's awesome.
Going well at your
Well,
work. So
maybe I'll finish this today, actually, now that I have this.
do no rush.